Every challenge question, part 49. This is Corpio 2, chapter 5, which is the chapter about polar coordinates. This question is kind of interesting. You get out a graph. R1 theta 1 is over here somewhere. And what this means is this length is R1 and this angle here is theta 1. And then R2 theta 2 is maybe somewhere up here. This angle or this length is R2. And then this whole angle from the x-axis around is theta 2. So I'll write it here, just say it's all of this. And they're asking us for the distance between the 2 points, like this distance here, d. And as soon as you look at this, you can think, well, actually, this is just cosine rule, and cosine rule very clearly appears here, so that's all cool. This angle here is theta 2 minus theta 1 to get this angle in there. And so d squared is equal to r1 squared plus r2 squared minus 2 lots of r1 times r2 times cos of theta 2 minus theta 1. All we have to do here is square root both sides, but also the way that I've drawn it means that this angle is theta 2 minus theta 1. But they've got it the other way around. That's okay because cos is an even function, so I can just times the input by -1 and I don't change anything. So I'm just going to square root both sides and do that, and we'll end up with the answer they wanted us. Of course, they just drew the picture with r1 theta 1 higher up than r2 theta 2, and then it worked out. But yeah, otherwise it's the same thing. Cool. So this point over here is found by making theta pi, 2 pi, 3 pi. So this is when theta is 3 pi, which means r is 3 pi k. And this one over here is, well, that's 0 to pi to 2 pi to 3 pi to 4 pi. So here r is 4 pi, sorry, theta is 4 pi, which means r is 4 pi k. So this distance is 4 pi k, this distance is 3 pi k. They add up to make 3. That means 7 pi k is 3, and that means k is 3 over 7 pi. Let's just write that in here, so therefore r is equal to 3 over 7 pi times theta. And now to do this area here, I'm kind of going to completely ignore what happens between 0 and pi and 2 pi, because if I count these areas, they're going to double count when I do the rest of the area, I think. So actually, I'm going to completely ignore that it does that, and I'm going to do this formula, this half r squared formula, d theta, and I'm going to do it between the line, well, here was 2 pi, wasn't it, to 3 pi. So let's integrate from 2 pi to 3 pi, half of r squared. R squared is just 9 over 49 pi squared theta squared. So let's do that. And then I'm also going to, that gets me this top area here. I'm also going to then do this area down here, which is the integral between 3 pi and 4 pi, written like this. And I'm going to take it away because between 3 pi, if I'm going from 4 pi to 3 pi, I'm sweeping out a negative area, which is okay because what I can do then is I can sweep out a positive area by going from 3 pi to 4 pi and swapping that to a positive and swapping those two signs over, I think. So that was my plan. I'm also going to factorize out half and 9 over 49 pi squared, which gets me all of this. Swap those over to get a plus here. Do some very easy integration, put some numbers in. These 9 pi cubes go away, which is very kind of them. So we just end up with this minus this, which is 56 over 3 pi cubes. And then if you just type that in, cancel the pi's, you can cancel it down to 12 over 7 pi's, which will be, I think, the answer to this question. Curve C has polar equation this, so remember as well that x is going to be r cos theta and y is r sine theta, just based on how polar coordinates work. Show the tangent is this. So I see the word tangent, I'm thinking dy by dx. Now there's a few issues here. I don't have an expression for y in terms of x, although I could maybe form one, but I want to be using this instead. So what I'm going to do is I'm going to say, well, substituting an r into here, I get x as roots 2 theta cos theta, and likewise into y here. And now to find dy by dx, I'm going to use this idea, d theta by dx times dy by d theta, because the d thetas cancel and you get dy by dx. So let's differentiate this one with respect to theta. That's going to require some product rule. It's going to be roots 2 times cos theta, differentiating that one, and then leave that one alone and differentiate that from minus sine theta. So we get this. Flip it over, because I'm actually looking for d theta by dx, which is this. And then here, dy by d theta, same kind of idea, product rule, differentiate the theta, make it go away, cos differentiates, sorry, sine differentiates straight to cos, we get this. And now we can just put those things together. This times this is just this one over the top of this one. And that will be dy by dx. That looks like a mess, but it's fine, because all I'm interested in is what dy by dx equals when theta is pi over 4. So let's put pi over 4 into here. This is nice, because sine and cos of pi over 4 is 1 over root 2. So all the root 2's just cancel, and you end up with 1 plus cancelling, and then this one is left over for pi over 4, so it's 1 plus pi over 4 over 1 minus pi over 4. I'm going to times top and bottom by 4, because I'm looking at the answer here. and I'm seeing that's the kind of thing that I have there, so I'm going to get this instead. And that's the gradient at pi over 4. Some more things I need is I need r at pi over 4. So at pi over 4, r is just root 2 pi over 4. And that helps me to get x and y at this point here at pi over 4. So if I put in this r into here and this pi over 4 into here, I get root 2 pi over 4 times cos of pi over 4, which is 1 over root 2. The root 2's cancel, and you're just left with pi over 4. And likewise for the y's, because sine of pi over 4 is the same as well. And this is everything I need. I want the equation of tangent. I have dy by dx at the relevant point. I have an x coordinate, I have a y coordinate. That means I can use y minus y1 equals mx minus x1. And I think I'm all good to go. So that's me doing this here. I'm going to times both sides by 4 minus theta, because again, I can see it happening over here. So that makes that. Not going to expand any of this out at all. I'm just going to say, if you do multiply this by this, it's the same as doing this times x minus this times this bracket here. And now finally, I'm going to do a little bit expanding. This makes minus pi, I think, at the front here, and plus pi squared over 4. And this makes minus pi, which is very convenient. Minus pi squared over 4, the pi's cancel, so that's all I'm going to do in this next step. Then I'm going to take away pi squared over 4 from both sides to create pi squared over 2. I'm going to times both sides by 2 here, along with moving this object to the other side, because I'm looking at the answer trying to get to it. Then times by 2, then times everything by minus 1. That flips this 4 minus 5 to be a pi minus 4. And flip 2 sides to be positives, and we arrive at what they wanted me to get. Thanks for watching. I'll see you next time.